So here we have a word equation. Carbon disulfide and carbon monoxide are formed. They're formed, so that means they're products. So they're on the right side of the arrow. Carbon with 2 sulfurs and carbon with 1 oxygen. Carbon monoxide I know is a gas, so I'm going to put its state symbol in there. By reacting carbon with sulfur dioxide. So the reactants, the ones that are doing the reacting, are just carbon and sulfur dioxide. Okay, so now we have the reaction. First thing we need to do, it has to be balanced, okay? If you do anything else before balancing it, you might forget and not go and do balancing before you do the Stoich. So anytime you see a reaction, make sure it's scientifically correct, or think about it like grammar. You wouldn't write a sentence that's horrible grammar-wise and just go, oh, I'll fix it later. You would just have made sure that it was right the first time. So I have 2 carbons, 2 carbons, 2 sulfurs, 2 sulfurs, which gives me 4 oxygen. Okay, so that's going to throw off my numbers here, huh? So 4 for the oxygen. Am I going to be able to fix that? Let's find out. Okay, 2 carbons would now be 5 carbons. So 5 carbons, 5 carbons, 2 sulfurs, 2 sulfurs, 4 oxygen, 4 oxygen. All right, so I was able to follow it out without going around multiple iterations or needing a balancing chart. If you needed a balancing chart to do that, no problem. That is the best way and decreases the chance of you having an error by visually looking at it. So that's balancing chart is always the best way. 3.4 moles of carbon. So I'm going to write that right above the carbon. React, okay? How many grams of carbon disulfide? Okay, so we're only caring about this, but we want to know grams this time. So we're going to have to go from moles to grams. Okay, so we start with what we know, 3.4 moles of carbon. We put that over 1, so we remind ourselves it's in the numerator. Make sure your fraction bars for this are always horizontal. The diagonal ones will end up you canceling out the wrong item. Moles, what do I always have to do? I have to use the mole ratio. You can't swim across to the other chemical. You have to use the mole ratio. Okay? So moles of carbon is on the top. And remember the rule for mole ratio is the unknown moles go on the top and the known moles go on the bottom, and you use the coefficients to determine those moles. So I don't use the 3.4 moles. That's what my experiment is. For the reaction, I need to know the ratio. There are 5 carbons needed to make 1 carbon disulfide. That is the mole ratio that our equation gives us. Okay, known is carbon, so moles of carbon goes on the bottom. Unknown, what I'm trying to find, moles of carbon disulfide. I have 5 moles of carbon for every 1 mole of carbon disulfide. Okay? So if I stop the problem right here, by simplifying, I could see my answer would be in moles of carbon disulfide. But it wants grams. So you can either look on your mole island map to figure out if you're multiplying or dividing, or you can say, okay, my known still goes on the bottom. So moles of carbon disulfide goes on the bottom. And grams of carbon disulfide goes on the top. Notice the molar mass has to have the same chemical on the top or the bottom. You can't go from moles of carbon to grams of carbon disulfide. We don't have a ratio for that. We have a ratio from moles of carbon to moles of carbon disulfide. We have a ratio from moles of carbon disulfide to grams of carbon disulfide. And that's using molar mass. Okay, so let's find out. Carbon disulfide has 1 carbon and 2 sulfurs. Carbon's 12.01 on the periodic table, and sulfur is 30, I always forget what the fraction after it is, 6, okay, 32.06. Okay. Okay. 76.13, if I did my math right in my head. Let me check with a calculator. 12.01 plus 2 times 32.06 76.13. Okay. So that's 76.13 grams in 1 mole. That's what molar mass is. Molar, 1 mole. Mass, grams. Just like molar volume is liters in 1 mole. Okay. So we have 76.13 grams in 1 mole. So now we can cancel out our moles of carbon disulfide. See why that horizontal bar is effective to make sure we're canceling off the right things. So my final answer is going to be in grams of carbon disulfide. Is that what I wanted? Yes, and that's why it's important to write your unknown. You can write it in guess format, you can write it in dimensional analysis format, or in Stoich format right above the formula, as long as you have it somewhere and connect to it, because oftentimes I would forget what the answer is and I would go too far on my conversions, and then I'd have to backtrack or get the problem wrong. You don't want to do that to yourself. So how do we do this? We find the numerator results, 3.4 times 1 times 76.13, divided by the denominator, 1 times 5 times 1. And what does that give us? 3.4 times 1 times 76.13, divided by just 5 in this case. Okay, if there was more things on the bottom, make sure you find the result of the numerator, find the result of the denominator, and then divide the two, or use parentheses on the bottom so that you don't end up flipping the guy to the wrong side. So always when you do these problems, check to make sure your math agrees with my math. I got 51.7684 grams of carbon disulfide. Okay, we solved it, and we now need to do sig figs. 2 sig figs in the original, so I only want to carry 2 important numbers for the answer. I can't leave it 51 because it's 51.7, so it's 52 grams of carbon disulfide.